Okay, so our unit today that we start today is on dosage calculations. And, right? There's actually a lot of little processes in calculating dosages that we have to get out of the way before we can get to the actual calculations themselves. And today we're going to talk about one of those, and that's something called a dilution. And a dilution is actually a very powerful little tool, and it is simply a ratio. We've talked about ratios before. Dilution is a ratio of parts of serum to total parts, or let's call it parts total solution. So if we have a 1 in 7 dilution, what that means is for every 1 unit, for every 1 part of serum. Now remember, serum is the generic word we're going to use for any sort of medication, active ingredient, whether it's rubbing alcohol, iodine, hydrochloric acid, or any of the medications. Marcaine, sorry, blanked out there. Marcaine, penicillin, insulin, anything like that we'd have to dilute. So for every 1 part of serum, there are 7 total parts solution. So remember when we talked about our ratios earlier, we said a lot of these ratios have hidden pieces in them, and here's one of them. If there are 7 total parts, and one of those parts is serum, that leaves 7 minus 1, or 6 parts of something else. And what we're going to call that something else is NS, which we've mentioned before can stand for either normal saline or neutral solution. Basically what it is it's sterile water. It's a diluent, it's a liquid that has no medicinal value. So when I look at a dilution like that, a dilution ratio, let's say we just have a 2 in 9 dilution. There are actually 3 ratios given there. One is the dilution itself, which again is the 2 in 9, where the 2 stands for the parts of serum, and the 9 stands for the parts of the total solution. But implied in that, and often is useful or even more useful than the dilution ratio, is the ratio of serum to saline, to NS. That ratio would be 2 to, if there's 9 total parts and 2 parts are serum, 9 minus 2 is 7 parts saline. Or again, another common ratio that's pulled out is the saline to total solution. So that would be 7 parts saline to 9 parts total solution. All 3 of those ratios are part of that when we're given that 2 in 9 dilution. And we have to be able to pick out which one we need in a given example. So let's do some examples and work with those ratios. So let's say this, in a 2 in 7 dilution, how much serum is required to mix 140 milligrams of total solution. So again, we have that dilution given, so let's start with that. So our dilution given here is 2 and 7. And let's remember what each of those stand for. The 2 is the serum. And of course, as in any dilution, the 7 is the total solution. Now let's look at the rest of our problem and see if that fits what we have. Well, we're given 140 milligrams of total solution. That does match with the total solution on the bottom of our proportion. Now the next big question is, this number here is the amount of serum. Is that what we are looking for? As we look at our problem, we see, yes, how much serum is required? So we cross multiply and divide. 2 times 140 divided by 7 is 40 milligrams. So to mix 140 milligrams of that 2 and 7 dilution, we would require 40 milligrams of the serum. In a 3 in 8 dilution. How much normal saline is required to mix 240 milligrams of solution? Now this time I didn't say total solution, but it's implied that is total solution. So we'll start out again. We'll take a look at our dilution. And our dilution is 3 to 8. And of course, the 3 is the serum. The 8 is the total solution again. And if we look at this, the 240 milligrams is again the total solution. This up here, however, represents serum, and that's not what we're looking for. We're looking for how much saline. Now we could cross multiply and divide here. 3 times 240 is 720 divided by 8 is 90 milligrams. We could cross multiply and divide and get that 90 milligrams for saline or for serum, and we can get the milligrams of saline by subtracting. 240 milligrams minus 90 milligrams gives us 150 milligrams of normal saline to finish that mixture. Or the other approach we could have taken is we could have converted this dilution, that ratio of serum to total, to a ratio of saline to total solution. There's still 8 parts total. If 3 of those parts were serum, 8 minus 3, or 5 of those parts, is saline. And now we can go ahead and set it up with 240 milligrams total. We can cross multiply and divide. 5 times 240 divided by 8 is 150 milligrams of saline. So we get the same result either way. Now, sometimes that works like that, where we can just use the dilution ratio and subtract like this. Sometimes we will have to do the conversion to that ratio of saline to total. And we'll look at that as we go through more examples here. For example, let's say, how much solution, let's do this, how much of a 1 in 8 dilution can be created using 280 milligrams of NS. So now in this case, we write down our dilution, which is 1 and 8. And I'm going to label it just because I always do. The 1 is the serum. The 8 is the total solution. Then we look at what we've been given here. We have 280 milligrams of NS. That doesn't match up with either one of those. So we have to redo our ratio to our ratio of saline to total. So our ratio of saline, if one part out of the 8, there's still 8 total parts. If one part out of the 8 is serum, 8 minus 1, or 7 parts is the saline. So then on the other side, the 280 milligrams of saline matches up with that. And we have to make sure, are we looking for the total solution? And we are. How much of a 1 in 8 dilution? How much of that dilution is asking how much of that total solution can we create? So then we go ahead and cross multiply and divide. 8 times 280 divided by 7 is 320 milligrams. Let's say we have an example like let's say in a 3 in 10 dilution. How much serum should be mixed with 350 milligrams of saline to create the solution? So again, we have a dilution here, and our dilution is 3 in 10. The 3, of course, represents the serum. The 10 represents the total solution. Well, here we have 350 milligrams of saline. That doesn't represent either one of them. So we need a ratio containing saline. But do we need the ratio of saline to total? Well, let's look at what we're looking for. We're given the saline. We want to know how much serum. So what we really want here is the ratio of serum to saline. The serum is still 3 parts. If out of 10 parts, 3 of those parts are serum, 10 minus 3 or 7 parts are saline. So we've created the ratio of serum to saline. And now we can put in 350 milligrams of saline, and we can cross multiply and divide. So 3 times 750 divided by, or 3 times 350 divided by 7 is 150 milligrams. So we would mix 150 milligrams of serum with that 350 milligrams of saline. So let's look at find the dilution created using 240 milligrams of NS to create 300 milligrams of solution. So again, if we are looking for a dilution The dilution has to be serum over total solution. Now here we are looking for the total solution. Find the dilution created. We have the total solution at 300. We do not, however, have the serum. So there's a couple of approaches. We can find the amount of serum here by just subtracting 300 milligrams total minus 240 milligrams of saline gives us 60 milligrams of serum. Now from there, it's a matter of just reducing that ratio. The milligrams cancel out. Both 60 and 300 divide by 60. 60 divided by 60 is 1, and 300 divided by 60 is 5, giving us a 1 in 5 dilution. The alternative way we could have looked at that is, since we didn't have the amount of serum, we could have done 240 milligrams out of 300 milligrams, which is the ratio of saline to total. And we could have reduced that ratio. Well, they're both still divisible by 60, giving us a 4 in 5 ratio of saline to total. And then converting that ratio, there's 5 total parts. If 4 of them are saline, 1 out of the 5 has to be serum. So as you can see with these dilutions, there's multiple ways of maneuvering to get to the final answer. Find the dilution created when 80 milligrams of serum are dissolved into 200 milligrams of saline. So again, we're looking for the dilution. Of course, the dilution is serum to total, but we don't have the total here. Well, one of the things we could do is we could put in the serum, 80 milligrams, and then remember that total is just the serum plus the saline, 80 milligrams plus 200 milligrams, which is 280 milligrams, and put that in for the total. And of course, looking for a dilution means we have to reduce that ratio. Milligrams cancel out. Both 80 and 280 will divide by 40. 80 divided by 40 is 2. 280 divided by 40 is 7, giving us a 2 in 7 dilution. Another way we could have gone about that without adding these together would have been to simply look at our ratio of serum to saline. We had 80 milligrams of serum to 200 milligrams of saline. We reduce. Milligrams cancel out. Those are still both divisible by 40. 80 divided by 40 is 2. 200 divided by 40 is 5. Well, if it's a 2 to 5 ratio of serum to saline, that means there's 2 parts of serum in. We add the 2 plus the 5 to get 7 total parts. So we get the same dilution again, no matter which way we approach the problem. Now, these dilutions are used a lot for doing testing. A lot of times we have to dilute a blood sample or a urine sample in order to test it. So we might be asked, how much NS should be combined with 250 microliters of urine to create a 2 in 9 dilution. So again, the dilution here is 2 in 9. Top number being serum, bottom number being total. Well, we have the serum. In this case, urine is our serum. That's our concentrate. We are looking for the amount of saline. Now we could plug this in. 250 microliters. I either put in MCL for microliters like I put above, or the textbook's going to use mu-L like that for microliter. And we can cross multiply and divide. 9 times 250 divided by 2. I believe that's 1125. Let me double check that. It is 1125. The units will be the same. That'll be microliters. So we would get a total solution of 1125, but we want to know how much saline is needed, so we have to subtract. 1125 microliters minus the 250 microliters is 875 microliters. Again, there's another alternative. We could have done the alternative of serum, in this case urine, to saline, which would have been 2 parts serum yet over 9 total parts minus the 2 parts of serum would be 7 parts of saline. And now we can find our answer without doing the subtraction. 250 microliters of urine. We cross multiply and divide. 2 times 250 divided by 2, or sorry, 7 times 250 divided by 2 is going to give us 875 microliters. So that's the basics of dilutions. Are there any questions so far? Okay. So where do these dilutions come in handy? Well, we've already seen it a little bit for prepping medications to dilute the concentration of the medication. But it's also going to be used a lot in testing. We had that last example with urine. Why would you ever want to dilute the urine for testing? Well, let's say we have a meter that is capable of reading up to 800 milligrams per deciliter. A blood sample exceeds this level. So we test this sample of blood with the meter, and it goes above that level. We get an error, or the meter somehow displays it has gone beyond its capacity. So what we're going to do is we're going to combine 80 milliliters of blood with let's go 240 milliliters of saline. Then we retest. to get a reading of 228 milligrams per deciliter. We want to know the true reading. So find the true reading. Well, the first thing we have to figure out here is we have to figure out what is the dilution that was used here. The dilution, remember, is again part serum to total part solution. So we have 80 milliliters of serum. Total parts, we have the 240 milliliters of blood, but we still had, 240 milliliters of solution, but we still had the 80 milliliters of blood that has to be added to that. So that ends up being 80 milliliters total over 320, the 240 plus 80 milliliters. So 80 milliliters of serum of blood in 320 total milliliters, and we reduce both of those numbers, divide by 80 to give me a 1 in 4 dilution. Now that we have the dilution, we use that dilution ratio to correct our meter. So the ratio of blood to total solution is 1 in 4. Well, this is the diluted reading. The actual reading should be larger than that because we diluted it, so we're going to make the reading smaller as we dilute it with water. So that means the 228 is smaller than the actual reading. So that 228 goes with the 1 in our proportion here. So 1 over 4 is equivalent to 228 milligrams per deciliter over our actual reading. So we will cross multiply and divide. 4 times 228 divided by 1 is going to give us 912 milligrams per deciliter is the true reading. So there's one application of these dilutions being used to take readings where the actual sample exceeds the capabilities of our meters. This used to be a lot more common than it is now. We have much more sophisticated meters with adjustable ranges. In fact, many of them are auto ranging, but it is a skill that is still necessary in a pinch when you're stuck with some more primitive equipment. So let's look at another example similar to that. So let's say, once again, the meter level is exceeded. So then we're going to use 300 microliters of urine in a 2 in 5 dilution. First thing we want to find is how much NS would you use in order to create that dilution. And the second thing we're going to find is if the diluted reading is 384 milligrams per deciliter, find the true reading. So find the actual level in the blood or in the urine. So we're going to start out here. We need a 2 in 5 dilution. Once again, I'm going to label it. The 2 is the serum. The 5 is the total solution. We don't want the total solution. We want to know how much saline, how much NS we need to add to that urine. So I'm going to adjust that and give myself the ratio of serum or urine to saline. In that ratio, there's still only 2 parts of urine. There's 5 total parts. 5 minus 2 is only 3 parts of saline. So we mix that. There's 300 microliters of urine that goes on, or serum that goes on top, which is urine. And we cross multiply and divide. 3 times 300 divided by 2 is 450 microliters of saline. So that's part 1. We need to add 450 microliters of saline to that urine to complete a 2 and 5 dilution. Now to find the true reading, when we take our dilution, which is the 2 and 5, 2 to 5, and remember, the true reading is always larger than the diluted reading. This is after we added water to it, so obviously it's going to be less concentrated. So that 384 goes with the smaller number, 384 milligrams per deciliter, and we'll cross multiply and divide. 5 times 384 divided by 2. I have to punch this one in. Gives us 960 milligrams per deciliter. That skill there, using the meters and dilutions with the meters, is one that people tend to struggle with. So I'm going to have you guys try one in your notes here quick. I'm going to give you about 2 minutes to work on it. But again, we're going to look at we exceed the meter limits. And we're going to give you an example. We're going to mix 80 milligrams of blood with 320 milligrams of saline. The meter reads 188 milligrams per deciliter. Find the true level. Try to find the true reading. I'm going to give you guys about a minute or 2 to work on that. Then we'll discuss that. I see a few people still writing, but let's go ahead and take a peek at what we did here. So we have the 80 milligrams of blood mixed with 320 milligrams of saline. So the first thing we have to do is figure out the dilution. Now we're not given the dilution, we're given the ingredients. So the dilution itself is found from those. Serum, which in this case is blood. The total is our dilution. The serum here is the 80 milligrams of blood. The total is the 80 milligrams of blood plus the 320 milligrams of saline. So that's 80 milligrams over 400 milligrams. We reduce that. Milligrams cancel out. Both 80 and 400 divide by 80 to give me 1 in 5. So we have a 1 in 5 dilution. Now we use that 1 in 5 dilution to adjust our meter reading. Our meter read 188 milligrams per deciliter. Again, that's going to be smaller than the true reading because that's after we've diluted it with water. So that 188 goes on top with the smaller number of our dilution, which is the 1. And we will cross multiply and divide. 5 times 188 divided by 1 is going to be, I believe, 940 milligrams per deciliter. So the actual reading there is 940 milligrams per deciliter. Now, I will say this, a little bit of a side note, doesn't have much to do with the math, but it has everything to do with the actual practice. Let's say the meter is plus or minus 2%. If we do a diluted sample like this, a 1 in 5 dilution, well, the diluted sample, the part that's here, has a plus or minus 2% error in it. Well, the same dilution ratio applies to that error as what applies to the actual reading. If we cross multiply and divide, 5 times the 2% divided by 1 means that the final amount could have as much as plus or minus 10% error in that reading. So we do have to be careful with these dilutions. If we're doing a diluted sample, we want to keep the dilution as small as possible, because the bigger the dilution, the more we magnify the reading that the meter gives us itself, but also the more we magnify the error in that meter. So let's say we have, we've exceeded our meter again. And we have let's just say we have 120 milliliter samples. So we may have taken a larger sample, but we've divided into 120 milliliter samples so that we can test it. Let's say that we're going to try to combine this to see if it'll get within our meter. So let's start with we combine it with 120 milliliters of normal saline. That's going to give us a dilution of serum to total of 120 milliliters of blood to our total is 120 milliliters of blood plus the 120 milliliters of saline gives 120 over 240. And many of you are probably ahead of me already. I've already reduced this. That's a 1 in 2 dilution. Well, what if we test that and it still freezes? So the meter still won't take that. Well, the process of testing is going to use up some of that sample. We had 240 milliliters total. Let's say that it used 40 milliliters to test it. So 200 milliliters of that 1 in 2 dilution remain. If I want to dilute that a second time, I have to work off of this amount. 1 in 2 dilution, that tells me if I cross multiply and divide, 1 times 200 divided by 2, that 100 milliliters of that is still the blood or the serum. So anything I go to dilute that with, when I go to calculate my new dilution, that new dilution is going to be figured off of 100 milliliters of serum or blood, and then the remaining amount, or the total, of 200 milliliters plus however much saline we've added to it. Let's say that we add an additional, 80 milliliters of saline. So that's now 100 to 280. The milliliters are going to cancel out. And that'll reduce, well, let's divide both of those by 20. That becomes a 5 and 14 dilution. So now let's say that we test that sample and it tests at 292 milligrams per deciliter. So now we use that 5 and 14. The 292 is, of course, the smaller number. It's going to get larger in actuality. And we cross multiply and divide. Oops, wrong button. 14 times 292 divided by 5 gives us, oops, that didn't work out. Let's try that again. 14 times 292 divided by 5 is 817.6 milligrams per deciliter is the true reading. So it is possible to keep going with these dilutions and adjust them. On Wednesday, we'll look at some easier ways to adjust these dilutions. For now, there is some homework in your book. Page 130 to 132, 1 through 37, the odds that it works on these dilutions and different ways of calculating with them. Again, make sure you do a bunch of these because the dilutions kind of set the basis for our other calculations as we move on. Anybody have any questions? Okay, well, we'll let you guys go then for the day. Have a good day, and we'll see you on Wednesday. Hopefully I'll have your tests graded and back to you by then. Talk to you later.